Okay, ladies and gentlemen, this is the beginning of section 2.4. Several things going on in 2.4. One of the things in section 2.4 has to do with symmetry. So the first thing we're asked to do is to sketch the function y equals the absolute value of x minus 3 and discuss its symmetry. So let's recall how to do that. Okay? Zoom 6 is going to give us a standard window. Y equals, and there's a couple places to find absolute value. Probably the quickest is to go down to the catalog menu. So that would be what? Second function 0. And that will pull up the absolute value function if you hit enter. So now we have y equals the absolute value of, and we're taking the absolute value of x. I'm going to close the parens, and then I'm going to subtract 3. And I'm going to graph. Okay, so what my graph basically looks like, and the absolute value shape is always a V. This V, if I hit the trace key, I can see that the y-intercept is 0, -3, which is also the lowest point on the graph. So for max and min, that's good to know. Okay, but basically here I'm not interested in max and min. So I take the graph. 0, -3 was the low point. Looks like a V. But what I was asked to do in this problem was to discuss its symmetry. Okay? And basically the correct answer here, this graph would be symmetric with respect to the y-axis. And there's a couple explanations. One is, if you look at the y-axis kind of cuts it in mirror images, cuts it right down the middle, okay? So on either side of the y-axis, if you cover it up, you're sort of getting a mirror image. What I like to remember in class, what I taught was, I called it the buddy system. If you pick a point on the curve, and if you think it's symmetric, if you're trying to see if it's symmetric with respect to the y-axis or x-axis or origin, whichever, you walk. So I walk to the y-axis. I walk the same distance away the other direction, and yes, I find a buddy. So the buddy system is a good way to see. So the correct answer here is y-axis. We have symmetry with respect to the y-axis. The next question asks us to sketch the reciprocal function and then discuss its symmetry. Okay, in class the other night we discussed the reciprocal function. If you weren't there and you're watching the video, the reciprocal function is the function y equals 1 over x, or 1 divided by x. So if I pull out my calculator, y equals, and I'll clear what's there. If I want to type in the reciprocal function, it's easy. I just hit 1 divided by x. Okay? And I hit graph. Weird looking little graph. We talked about that in class. What's actually going on there? Okay? We make it clearer here in a picture. What's actually going on there? Let me remind you what we did in class. This graph has two branches. It has a branch in quadrant 1, and it has a branch in quadrant 3. And the graph actually has two asymptotes. The y-axis is an asymptote. It's a line that the graph gets closer to but never touches, and so is the x. So this is actually a graph that has both a horizontal and a vertical asymptote. So that's kind of nice to, that's kind of nice to know. Those are important facts to know. What we were asked here, though, was not about asymptotes. We were asked to discuss its symmetry. So the first thing I want you to know is what the reciprocal function is. It's the function y equals 1 divided by x. And if I was discussing its symmetry, the correct answer would be it's symmetric with respect to the origin. And here's how I can see that. If I pick a point on this branch and I walk to the origin, okay, and then I continue walking away from the origin in the other direction but the same distance, I find another point on the curve. I find a buddy. So the buddy system is a very informal but yet very good way of determining where you have symmetry. So the reciprocal function is symmetric with respect to, so when it says discuss the symmetry, it's symmetric with respect to the origin. And we're done.